So here we're going in. So now we have this. Okay. We have O, H, H plus. Right? Okay. So those of you who have taken my class before, I call this the African water, where basically this random water from, I already had H2O, where did this other water come from? You just write another water here, because your beaker has lots and lots of water. Okay, so I pick Africa because I figured, I think I discussed it, right? Yeah. So anyway, the African water comes along and grabs one of these H's. Again, you got to release it, and that gives you your Chem diol. And so this is what I call the cleanup stage, right? You've added everything there, you just need to take away one of the H's to make everybody happy. So this is really just the cleanup stage. H2O will come in, grab the H, make back your H3O, which is, so that's why it's a catalyst, right? You use it up, you make it back. So if I start with H3O, I better end up with some H3O at the end. Okay? So this was pretty easy, not too bad, right? I mean, it's not as bad as Emmy. Okay? I have an answer. Oh, you got to go backwards now. So go backwards. So make the diol and go back to the ketone. Go.
How do we know it's an acid or base?
Go back. You have all the steps, so go backwards. Huh?
How do we know if it's an acid or base addition?
I will tell you. On the quiz, I'll say, do the base catalyzed addition of water. Do the acid catalyzed, I will tell you.
Okay.
Yes.
Didn't it say, like, to push it to, I think it's like the right table water?
Correct. Because remember, this is not a favorable reaction to have water come in. So if you suck away the water, it drives it to make more water, like equilibrium.
So then, it said to just add excess water to
Backwards. Because you make it so much water, it uses up the water to go back to the Let's go backwards. Add that H back on. So when you add that H back on, isn't this OH2 plus? Isn't that what we had right here? Okay, so go ahead and draw that. Okay, so everybody have the OH2? That's a great leaving group, huh?
Yeah.
Let's go ahead and make it go away, shall we? All right, so go ahead and pop it off. Now, if you pop it off, aren't you going to make a carbocation?
Yep.
Okay, so you pop that off. Sorry. Okay, so water is a great leaving group. So let's go ahead and take that off. So everybody should have. Oops. Undo. Nope, that was bad. Redo? I don't know how to do redo. Oh, crap.
I don't know.
I pushed that.
I
guess that's not what I was supposed to push.
Yeah, this is the eraser if you want to erase, so.
I'll just draw it again.
Yeah, I'm not sure where.
All right. So,
Let's restart.
yeah. Okay, so this really should be this with a positive right there. Right? Because water just left. Anybody close by that can help that guy?
Oxygen.
Yeah, the oxygen's got some dots, so let's bring those dots back down. So, this is looking more like what I want. Double bond O with the H still stuck on there. All right. So a water will come in and grab that H and release it back there, and we're back to our carbonyl.
That's why.
That's how you go backwards and forwards. Who is lost? Let me come around and help. Okay, so basically you add an H back to one of the OHs, make it water, make it pop off, and then bring back that carbonyl. Same thing forwards. You have a carbonyl, bring in the water. Okay, so it's both, it's just backwards and forwards.
So you can just add water whenever, pretty much.
Yes. You add water whenever. You need water, go to Africa, find some, bring it in. Yes.
African water.
African water. Anytime you need water, go find some.
And then you're left off with the carbonyl group and the H3O.
H3O plus. It's acid catalyst, that makes sense, because you added H3O to begin with, now you brought it back. Okay? All right, can we move on, or does anybody need help? Everybody good? All right, great. So let's go to the... Huh?
Oh, no.
No? Oh, no. Okay. All right. Now, let's say it's not H2O. All right? Why don't we add something else with an O? An alcohol. Right? I mean, with the water, didn't you have the O with the dots come in? Well, why don't we just do O on an alcohol instead? Let's just see. Let's just see. Okay. So before, what happened? One OH came, and where did it come from? The carbonyl, right? Because the carbonyl had an O and grabbed an H, so that's where one of the OHs came from. Where's the other OH come from before? Yeah, the water come in, right? Here's one OH, but the second OH came from the water. All right? This time, same as above, okay? The first OH, okay, is going to come from the carbonyl. We got that. But the second part is going to be, we're going to be using an OH instead of water. So instead of an H2O coming in, we're just going to have an alcohol come in. Okay? All right? And you keep going. So that's the other strange thing about this, is you can also add a second alcohol. I'll talk to you how in just a little bit. So that's a little different than before. All right? Okay, so, all right. Now, let's do this mechanism. All right, so we've got our cyclopentanone. For those of you who are reviewing how to name, cyclopentanone. And we're going to add an alcohol. So my first question is it neutral or is it negative? It is neutral. So what's the first step I've got to do? Protonate the oxygen. Okay, anytime you're neutral, you've got to protonate that oxygen. Okay, so assumed in this is H3O+. Okay, so I forgot to put that in there, so I'm sorry, but assume that there's H3O+ there. All right? Okay, so what's my first step? Protonate that O. Can you guys do that for me? All right, I'm assuming you can do that, so I'm just going to redraw it right here and just assume, because you know what they say when you assume, all right, that you all can get to that. Yes? Do we need to go over that? Okay, so we're at the OH with the plus. Jessica, you need help with that? Can I help you with that? No? Marcus? Candace? Isaac? Anna? Anybody need help with that? Right? O grabs an H, then the double bond moves up, and you should have a plus there at the little house chimney. Right? Okay, so what's going to come in? Normally, what do? We had water come in. Right? But this time we're not doing water, we're doing an alcohol. So how do you think this alcohol is going to come in? The dots from the O come and attack. Okay, go ahead and do that for me. So the O from the alcohol, whoops. You're not recording anymore? Oh, yeah. All right. So draw me what you got. And I need a formal charge, please. All right, how'd you guys do? All right, so did everybody get what I got here? You have the alcohol added, and the OH is there from the carbonyl, and there's an H hanging off of that. So just like before we cleaned up the water, let's go ahead and clean this. And what do we need to clean it with? Agua de la Africa. Yes, so bring in another H2O. Okay, bring in another H2O. Ah, thank you. How'd you know what I was looking for? Fat fingers, yes. So we got another water, okay, coming in. And now don't attack that H. Oh, excuse me. Attack that H, and then...
You said don't?
I'm sorry. Don't attack the O is what I meant. Because a lot of people see the O plus, and they're like, ooh, O plus, O minus. No, because then the O would have too many bonds. You want to grab the H, all right?
It's already
and then,
bad for having an extra bond.
I know. It's already upset with being, yeah. So everybody... If you got caught up, and you sort of understand kind of what I'm saying, we should have something like that with dots like that. So how do you guys feel about that?
Good.
Yeah? How do you guys feel about that? O, this with an OH. So it's not a diol, a Chem diol, because there's not two OHs. It's an alcohol with an ether. Does anybody know from the reading, what is that called?
There was a
Hemiacetal, right? So it's like hemi, like a truck, right? So hemi, I don't know what hemi means. I should have looked it up, but I don't, okay? But anyway, what, half, is that what that means, hemi? So when they say a Chevy, I've got a hemi, what does that mean?
It's a hemispherical, it has to do with the cylinders and how they're shaped.
Thank you. So basically a cylinder in the, you know, I don't know if you guys know how cars work, but there's a big cylinder of steel, and it moves up and down in it's like a hole, and it goes up and down. Well, basically you have gas, and it sparks, and it pushes the piston up. Well, when it pushes the piston up, it turns your crankshaft, and that turns your wheels. And then it compresses back down and turns the wheels more. So it goes up and down, it turns your... So V8 means there's 8 cylinders turning your wheels. A V6 means there's only 6 cylinders moving your wheels. So apparently, I guess a hemi would be, instead of being a cylinder, they're half moons.
Well, it's the top of it. Normally, cylinders like flat on top.
Ah.
But the hemi has, well, not the new ones. The new ones are just the name, but the old ones actually had...
Like a dome top. Interesting. And that helped, I guess, with the displacement?
I have no idea.
Okay. But anyway, if somebody says 3.8 liters, what they mean is if you filled out all those chambers with water and you measured it, it holds 3.8 liters. Well, obviously, the more space you have in there, the more power you can get from those pistons going up and down, which will turn your wheels. A lot of people don't realize that. I mean, V8 sounds better than V6, but that's because you have 8 cylinders moving your tires instead of 6 of them. It's kind of interesting. So anyway, hemi means part or half, like hemisphere. Yeah, I knew that one. Okay, so we're half of an acetal. So what's an acetal? It's got 2. So basically, you need to know a hemiacetal has an alcohol and an, what's the functional group here? Does anybody know? COC. Anybody know when you have a carbon with an oxygen, not double bonded, with another carbon? Ether. Okay, so when you have an alcohol and ether, it's called a hemiacetal. Good. All right. Let's do the reverse. I'm not kidding. Oh, we got to keep going. Okay, we got to keep going. Okay, sorry. We got to go to the acetal. I'm sorry. Okay, so now what?
Now we do
And add an OH so that can leave.
Yeah, let's get rid of that OH. That's a great idea. Okay, so Farzan got it. We're going to grab an H from this guy. All right, to make it water. All right. I mean, we need to get it to go away, because we're going to do the exact same thing we did the first time, which is bring in another alcohol. I mean, you're just doing it twice. That's all you're doing. So you should have a carbocation with this guy here, right? And then your other alcohol will come in, just like it did before, and you clean it up with some African water, and you should end up here. It's literally the exact same thing you just did. You're just doing it twice. Who's lost? Let me help you. Who's lost? That's a positive there. That's where it wants to be. Okay. All right. We'll stop this one here. Do I push pause or do I push record?